Okay, hey everyone. Today I'll be doing the week 3 physics quiz. So question 1. Fill in the blanks. A lightning conductor helps protect all buildings from being struck by lightning. It consists of a thick copper strip on the outside of the building, connecting to the metal spikes at the top, to a metal plate at the ground, as shown below the diagram. Okay, this memorized essentially, but let me explain it to you. So we start off here. The lightning strikes this long thing, right? The charges go through to the spikes. Okay, the stream of positive air molecules, because this is from the lightning, it goes to the spikes. The spikes, since it's made of metal, right? Because they said here a lightning conductor, whatever. It's supposed to be made of metal, so it can conduct, or just a really good conductor in general. It takes the charges from here down along the copper strip, all the way down to the here to the earth. As you can see, electrons repel to the earth. Here it just keeps them uh, to the plate in the ground. Okay, this why? So you can earth it. This is earthing. When you earth something, the earth or a much larger conductor will absorb it, and you, if you were in the tall building, would barely be able to feel anything. If you were to be able to feel anything at all. Okay, question 2. Which of the following statements describe an electric field? It has a magnitude and direction, and the magnitude is force over charge. Obviously, because it's not going to be scalar, since we just said it has a magnitude and direction, and it is best described using charged spheres. This is wrong, and ignore this last one. I have no idea what this means. They said force, so like I don't know why it would say work. Like since we just answered it here. Anyways, question 3. Which statements are true about the role of charged particles in electric conduction? In metals, only electrons can move. Obviously, you should know this because metals have free electrons that move around. This is what causes conduction. Essentially, the electrons carry the. I don't need to explain it. I explained it last week, and you should know this from chemistry. In an insulator, all electrons are fixed at specific locations, and in semiconductors, gaps left by electrons can cause conduction. Okay. Which statements are true about the electrostatic spray gun? This is another application, like the first question. This is an application of electrostatics. Please read them. You don't really need to memorize anything. All you need to memorize is from the quiz, really. Just read them, get a good look at them, and you should be good to go. They only ask these 2 questions, as far as I know. So what's true? Charged paint particles are attracted to a grounded surface, and the paint spray gun advantage is it's an even distribution of paint. Okay, question 5. Which of the following can be referred to as an electric current? A flow of positive charges and a flow of negative charges. An electric current is a flow of charges in general. Charged charges, keep in mind, it's a charge. Obviously, it's not going to be neutral atom, and it's not random motion because we know a current is a flow. So it's only going to be positive charges and negative charges, and it has to flow. Okay, indicate, consider a simple cell showing the cells made of a battery, blah, 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 blah. Okay, then the electrons in the circuit move from A to B. Because here you notice that the lamp is here. Listen, this is like kind of a dumb question. They like if they do ask it to you, it's not something I can really explain, but it's something that you have to like infer. Because here you can see it doesn't go properly. Okay, anyways, the conventional current flows from B to A. You should know it flows from the positive terminal to the negative terminal. Here it's just not conventional. I don't know why. Okay. The electric field patterns around charged particles are shown in A and B. Okay, particle S is positive, as you can see, because the lines are going to this way, so it's positive. Since they're both attractive, like the lines are joined, that means it's opposite charges. So here, if this is positive, then here it's going to be negative. Okay, here you can see they're repelled. So obviously, they're both going to be the same charge. And if it follows the direction of the line, it's going to be positive. So these 2 are positive. Okay, question 8. When another charge, okay, the first, this is spread out away. When they come closer, okay. So this was charged positively, and they moved away, right? This was initially charged positively, the electroscope. They moved away, right? So they got charged. They both got charged with positive charges. Now, when another charged rod W is brought closer to the metal rod, the goldies come closer together. They got close together. They joined, kind of. What this means is that they're both attracting, right? They're both attracting to this charge that's on W. What does this mean? This means that they're opposite charges. And we know here that if they were positively charged initially and they attract to opposite charges, it's going to be negative. Okay, question 9. In a circuit, 3 coulombs of charge flow each 0.6 seconds. The current is, you have to memorize the formula. Let me just get the open board. So, open board. desktop. Okay. You need to memorize the formula. Q equals to the charge, or sorry, this is the current is not Q, it's I. I equals to Q is the charge. Q over T. Now you can memorize it as Q equals to IT. Whatever way you want to memorize it. Anyways, we're concerned about the I, the current, so we divide the charge, which is 3 coulombs. So I equals to 3 over 0.6, which is the time, because you want it in seconds. This will give us, do it on a calculator, 5. 5 amperes. Okay, moving on. Question 10. Although charge cannot move through the body of the insulator, charge can be slightly displaced within each molecule, resulting in a net induced opposite charge slightly nearer to the inducing charge. This is describing how an insulator is attracted by a charged body. Honestly, you remember, this entire quiz is really memorization. There's not really something I can explain here. But I'll try to make it clear. Although charge cannot move through the body, so you know that insulators conserve the charges. They don't let charge flow through. The charge can can move, not move. You know what displacement is? We took it last year. It can be displaced slightly within each molecule. So the charge kind of transfers a bit. Right? It's not because again, there's nothing as a perfect insulator. There's something that blocks charges completely. Charges will flow just very slowly and very poorly, right, in an insulator. So you still have charges, right? You still have charges in there, which results in a net induced opposite charge slightly nearer to the induced charge, because again they attract and you have the charges transferring. Okay, question 11. I'm gonna skip this. You should know this. Question 12. I'm gonna skip this again. It's negatively charged particles is an electron, and positively charged particle is a proton. Okay. Which of the following is true about the Van de Graaff generator? Produces enormously large static electric potentials. Obviously, it generates static electricity. Again, it's a generator. That's what it does. And it's made up of a lower roller. I explained this last week, and again, I think it's coming to this week's quiz. I think I remember I saw it. I'll explain it again there. But yes, essentially, it is made up of a lower roller that acts as a charger and a dome that collects the charges. It doesn't measure anything. It's a generator, and it doesn't create fields because again, this is electrostatic, not magnetism. Don't mix them up. Charges neutral materials with electrostatic induction. No, there's nothing such as induction in a Van de Graaff generator. Okay, write the equation for the electric field E. This is the force over charge thing that we talked about initially. This is the formula. E equals F over Q. Memorize it. I don't know if they'll ask you to calculate. I think they might in an actual AMS. I think they asked you as well, but we're not sure. Okay, anyways, this came in the periodic today. An electric field is described by electric lines of force. Again, remember, if the lines are going outside of it, like for example, when we saw the electric charges, they moved like this, right? The lines moved like this. This is the positive terminal then, and wherever they're receiving is the negative terminal. So this is all you need to really need to remember. So here, since the lines are leaving, so it's going to be positive, and here, since the lines are coming in, it's negative. Okay, question 16. Scientists have agreed to adopt a convection that from the positive terminal to the negative terminal of a generator. You should know this. This was in grade 7 science. Objects become charged when they gain or lose electrons. Yes, obviously, that's the definition of an ion, if you think about it. And electrons have a negative charge, protons have positive charge. An object that gains electrons acquires a negative charge. You all know this from basic science. A neutral conducting sphere is hung by a thread to a positively charged rod. Which of the following will happen? Okay. Since it's neutral and it's hanged, right? It's hanged by a sphere, by a thread, sorry. Since you have a positively charged rod, again, we explained it. There's going to be a transfer of charges, right? So in the thing, and it's conducting. So there's going to be a charge. Like this is induction. So you're going to be charged, and then so they're going to attract, right? This is going to attract to that, which is essentially what the answer is. The sphere will be attracted to the rod. Question 19. The force between two equal charges. I explained this before, but we'll explain it again. The formula is F equals to K times the absolute value of Q1, Q2 over r squared, where r is the distance. Okay, now we're not really concerned about anything here, right? Only the f and the r. So f is obviously inversely proportional to r. So we're gonna do it f2 over f1 equals to r1 over r2. And since you know that this is squared here, so we're gonna have to square this. This is the formula you need to know. You can also do f1 over f2, r2 over r1 squared. It's the thing, they're ratios anyway, they'll give you the same answer. So let's do it on a calculator first. Let's substitute in our values. F2 is, we don't know, we're just gonna hide it. I'm gonna keep it F2 over F1 is 1.2 millinewtons. So, and we're gonna keep it millinewtons because it's the final answer is in millinewtons, equals to R1 is 2 centimeters. So meter Newton, sorry, meter Newton. This is not milli, meter Newton. So 2 centimeters to meters is going to be 2 times 10 to the power of negative 2 meters over 0.5 times 10 to the power of negative 2 squared. Okay, cross multiply. You can either do it on a calculator if you have an equation solver. Let's do that. If not, you cross multiply. First, you solve this, right? So f2 over 1.2. Let's do this part on a calculator. Open a bracket. 2 times 10 to the power of negative 2 over 0.5 times 10 to the power of negative 2. No, times 10 to the power of negative 2. There we go. All squared. 1 second. All squared, so 2 times 10 to the power of negative 2 over 0.5 times 10 to the power of negative 2 squared will give you 16. So f2 over 1.2 equals to 16 over 1. Why over 1? You can just write it 16, you can write it over 1 sign. f2 equals to 1.2 times 16, because again you cross multiplied 1 times f2, which is f2, 1.2 times 16. So f2 equals to, you do it on a calculator, 1.2 times 16, 96.5, which is 19.2. You round it to 19 meter Newton. I think they accept 19.2 as well. I mean, they should. I don't think they mind. Yeah, 19.2. It's fine. Okay, question 20. In a simple Van de Graaff generator, when the motor is on, the roller acquires a negative charge from a rubber belt, which builds a positive charge. Obviously, because the positive charge, it's gonna go, right? I explained this in the previous video if you want an in-depth explanation. But yeah, I'm just gonna summarize. So the roller is gonna acquire a negative charge from the rubber belt. This is gonna build a positive charge on the thing. By the means of the two brush assemblies, the negative charge is drained to the earth, leaving the positive charges. Since they attract, right? The charges attract, so the positive is gonna come to the negative, so it's gonna like slightly get there. The negative charges that's there is gonna leave, is gonna get drained because remember the negative charges move, get drained to earth. So that just leaves the positive charges in the actual roller, right? This roller moves up to the dome. This roller moves up to the dome and leaves the positive charges there, and then the cycle repeats. It rolls back down and the same thing happens. Okay, a force acting on a 30 nanocoulomb charge at a certain point is 2.4 micronewtons. Okay, so you have to remember F equals to so let's just go back to the formula because I don't want to write it in another way. They don't really want me to write it down in here, I think, right? It's not this one. Okay, I'm just gonna have to look for this one now, aren't I? It's not, now you can't get the force actually. Let me just use the way they use it. Here, okay. We're gonna copy it. It's actually, I mean, technically speaking, the way the book writes it is actually F equals to EQ, right? But you can write E equals to F over Q. It's fine. So we'll just keep it like this, the way they want it. Okay. So let's move on to the last question. Here. I was here. Yeah. Okay. So we copy it down. E equals to F over Q. Where's the F? The F is this one, micronewtons. So remember, micro means 10 to the power of negative 6. And nano, this is nanocoulomb. Nano means 10 to the power of negative 9. So this is actually 2.4 times 10 to the power of negative 6 newtons over 30 times 10 to the power of negative 9 coulombs. Right? So E equals, to redivide this, so we just put it on a calculator, 2.4 times 10 to the power of negative 6 and 30 times 10 to the power of negative 9. You get 80. 80 newtons over coulombs. Newtons per coulomb, actually, so it's fine. Okay, moving on to the last question of this week. Electrons of 20 microcoulombs charge are transferred from metal plate A to metal plate B via conducting rods. The charge is transferred in 5 milliseconds. Okay. So you know that Q equals 2IT, which means that I is equal to Q over T. And we just said this means 10 to the power of negative 6. This is milliseconds, so 10 to the power of negative 3, which means that this is actually 20 times 10 to the power of negative 6. Or this one, they want it in milliamperes. It's fine, whatever. We can convert it later. 20 times 10 to the power of negative 6 over 10, what was it? 5 times 10 to the power of negative 3. This is in coulombs, one like not nano, not nothing, and seconds, right? So because we want to change it to milli, we get this too, right? We put them in their normal like states, not milli, not nano, no prefix before it. Then we multiply by 1,000 to change it to milli. So first, so let's just divide this now. Let's see what we got. 20 times 10 to the power of negative 6 over 5 times 10 to the power of negative 3. You get 4 times 10 to the power of negative 3. Amperes, right? This is the ampere. This is not milliampere like they want. So what we do, we multiply by 10 to the power of 3. So 4 times 10 to the power of negative 3 times 10 to the power of 3. This negative 3 and 3 cancel out, so the entire thing cancels out. You just get 4, and this is what you put in. Okay, that's the entire quiz for the day. Good luck, guys, tomorrow. Have a good day. So I'm just end it here.